Welcome to all. In this video, we are going to see the ore concentration methods. In the part 1 video, we have seen two methods. One is hydraulic washing or gravity separation, and the second one is froth flotation process. And as of now, in this second video, that is part 2, we are going to see the remaining two ore concentration methods. So the third one is magnetic separation and the fourth one is leaching. We are going to see about the methods involved in ore concentration. So before entering into the topic of ore concentration, let us see what is ore concentration. So before entering into ore concentration, let us see the metallurgical processes. So what do you mean by a metal and what do you mean by metallurgy? So metallurgy relate to the science and technology of metals. So from the available sources, we can extract the pure metal. So the processes involved in the extraction of metals are called metallurgy. A naturally occurring substance obtained by mining which contains the metal in free state or in the form of compounds like oxides or sulfide, which is called a mineral. Minerals that contain a high percentage of metal. There may be so many minerals available, but the minerals in which the metal should contain in a high percentage and also which can be extracted conveniently and economically are called ores. So hence all metals are not ores, but all ores are included in the minerals. The extraction of the metal of interest from its ore consists of majorly three main classification of metallurgical processes. The first step is concentration of the ore, and the second step is extraction of crude metal from the concentrated ore, and the third step is refining of the crude metal to get it in a pure form. The extraction of crude metals from the concentrated ore is carried out in two steps, namely conversion of the ore into oxides of the metal of interest and reduction of the metal oxides to elemental metals. So, he is the person called Harold Johann Thomas Ellingham. So, he was a British physical chemist. He was a British physical chemist. He did enormous work in the field of metallurgy. So many metallurgical processes. So, he only established. So, occurrence of metals. First, we have to find out from where we can able to get the metals. In general, pure metals are shiny and malleable. However, most of them are found in nature as compounds with different properties. So, for example, metal having least chemical reactivity such as copper, silver, gold and platinum occur in significant amounts as native elements. Reactive metals such as alkali metals usually occurs in their combined state with other elements and are extracted using suitable metallurgical processes. So in the screen you are seeing a metal means a mineral of copper, so which is nothing but malachite. So before entering into the subject, what do you mean by a mineral and what do you mean by a ore? A naturally occurring substance obtained by mining which contains the metal in free state or in the form of compounds like oxides and sulfides is called mineral. However, from which mineral the necessary material can be extracted conveniently and economically are called ores. Hence, all ores are minerals, but all the minerals are not ores. So these are all the three main classification of metallurgical processes. First step is ore concentration, and the second one is isolation, and the third step is purification. So what do you mean by metallurgy? Again the three steps involved: concentration of ore, and isolation of metal from concentrated ore, and purification of the metal. So these are all the total process of metallurgy. So the first step, the ore can be converted into a powdered ore. Next step is ore concentration. So the ore concentration involves 4 or 5 processes. One is hydraulic washing, and the second one is froth flotation, and the third one is magnetic separation, and the fourth one is electrostatic separation, and the fifth one is leaching. So during the process of ore concentration, we are removing the gangue materials. After the ore concentration, the concentrated ore can be converted into a crude metal by 5 different processes. After getting the crude metal, we can get the pure metal from the crude metal. The process is called refining or extra purification, by which we can get a pure metal from the impure metal. So today in this video we are going to see only about the ore concentration processes. So before entering into the ore concentration processes, so what do you mean by a mineral, ore and flux? Because all those terms we are going to use in the upcoming slides. So mineral. So what do you mean by mineral? A solid, naturally occurring inorganic substance formed by geological processes is called a mineral. Then what do you mean by a ore? A naturally occurring solid material from which a metal or valuable mineral can be extracted is called a ore. And what do you mean by flux? It is a chemical cleaning agent used for purification of the ores. And what do you mean by slag? Slag is nothing but the waste matter separated from metals during the extraction process. And what do you mean by gangue? During the mining process, gangue is commercially worthless material that surrounds or it closely mixed with the it can be unwanted material, but it is closely mixed with the wanted material in an ore deposit. So we can remove the gangue material by ore concentration processes. So minerals, again the combined state of metal is in the earth crust is called minerals. Most of the cases the minerals are available in the form of oxides or carbonates. And ore is nothing but the mineral from which the metal is economically and commercially extracted. For example, for aluminium extraction, we can use the mineral bauxite acids ore, and for iron, we can use hematite as a ore. All ores are minerals, but all minerals are not ores. And gangue, what do you mean by gangue material? So impurities present in minerals such as silicates and rock pieces and some sands like materials are called gangue. So metallurgical processes. So in the previous slides I have told 3 main processes. One is ore concentration, and from the concentrated ore we can extract the metal and refining the impure metal into a pure form. So in addition to that, another one step is crushing and pulverization, in which high and huge pieces of the minerals can be broken into small pieces. So huge pieces are broken into small pieces. So this process is called crushing and pulverization. So after crushing and pulverization, we can get a good ore of a mineral, from which we can able to isolate our metal. So the ore concentration processes involved 3 or 4 major steps. One is gravity separation, which is otherwise called hydraulic washing, and the second process is froth flotation, and the third one is magnetic separation, and the fourth one is leaching. So we are going to see one by one. In this part 2 video, we are going to see about magnetic separation and leaching. We are going to see magnetic separation. Next we are going to see magnetic separation processes. So which is used for the ore or gang, in which either one should have a magnetic behavior, either the gang particle or the ore particle, any one should contain magnetic behavior. So in this process, the instrumentation setup contains a moving belt which is connected with the two wheels. Among the two wheels, the right side wheel is not a magnetic one, but the left side wheel is a magnetic roller which is having the magnetic property. Again I am telling, the right side wheel is not having magnetic property, magnetic behavior, but the left side wheel which is magnetic roller, and a moving belt is connected between the two rings, and which is moving from right side to left side as depicted in the picture. So above the belt, the powdered ore is poured. The powdered ore through a big funnel, it is poured into the moving belt. Now while moving the belt, so the entire material comes near to the magnetic roller, and in between the two rollers, the powder ore is moving, and when it reaches the magnetic roller, so below the magnetic roller, two containers we have kept. One is for magnetic items, and another one is for non-magnetic items. So here the word I am using only items because anyone can be magnetic property. So either the ore should have the magnetic behavior, or the gang material should have the magnetic behavior. But the condition for separating the minerals or ores using this magnetic property is either one should have the magnetic behavior, and other should not. Then only we can able to separate. Now while coming the belt at the end, so while rotating the wheel, the contaminants in the ore which is not having magnetic property immediately fall down from the belt, so it is directly below the container. So immediately after reaching the ring, it will fall immediately because there is no at the end there is no place to keep. So because of gravitation, immediately it will come down. But the magnetic items, magnetic contaminants, which can be connected or magnetically attracted by the rolling wheel. So the left side wheel is a magnetic roller, so in which the magnetic contaminants or magnetic constituents will go till the end of the ring. So till the end of the ring. So up to this it will connect. Till the end of the ring it will connect, and from there only the connection of magnetic behavior is disconnected. So after that, so the belt is moving on the right side. So the contact between the magnetic contaminants, constituents, and the magnetic roller is disconnected, and hence the particles are collected in the second container, which is kept little bit right side on below the magnetic roller. So here the magnetic contaminants are collected in the second container, and the non-magnetic contaminants collected in the first container. So in here we can able to separate these two. So the condition is either one should be magnetic, either the gang or ore material, any one should be magnetic and the other one should not be magnetic. So this method is applicable to ferromagnetic ores, and it is based on the difference in the magnetic properties of the ore and the impurities. For example, tin stone can be separated from wolframite impurities, which is magnetic. Similarly, ores such as chromite, pyroslate, having magnetic property can be removed from non-magnetic silicose materials. So this is another picture for the magnetic separation. So the powdered ore is poured from the top and it is followed on the moving belt. The moving belt is connected with the two wheels. The right side wheel is not a magnetic wheel and the left side wheel is a magnetic wheel. So because of the magnetic property, the contaminants which is having either the gangue or ore which is having the magnetic property falls little far distance after disconnection from the magnetic wheel and collected at the right side container. The constituents which is having not non-magnetic property or non-magnetic ore or non-magnetic gangue materials can be collected in the first container itself, which falls because of gravitation immediately after the wheel is rotating. So through which we can able to separate the magnetic property, the constituents which is having magnetic ores and magnetic gangues can be removed by this magnetic separation method. And the last one is leaching process. Leaching is the process in which the ore is concentrated by a chemical reaction. So for example, leaching of alumina from bauxite ore. From the bauxite ore, while we are adding sodium hydroxide, it is converted into sodium meta-aluminate. Similarly, argentite ore, while adding sodium cyanide, it will be converted into a sodium argentocyanide. So in this process, from the available ore, we can able to convert only the required mineral and converting using a chemical processes. So leaching is a chemical separation. It involves the treatment of the ore which is suitable with a suitable reagent to make it a soluble while impurities remain insoluble. Only the required metal alone soluble by using the chemical and the remaining impurities retained as insoluble gangue material. The soluble impurities are separated by filtration. The impurities in this case include not only gangue but also chemical entities which are not solubilized during the leaching preparation. So here one example we have given. So leaching of alumina from bauxite ore. So the bauxite ore contains so many other contaminants from which only the alumina Al2O3 and dihydrate alumina alone can be treated with sodium hydroxide in presence of water and converted into sodium aluminate, which is soluble in water. So the remaining unwanted gangue materials can be removed. The solution of sodium aluminate is filtered, and after removing by filtration, we can get the alumina alone, and the alumina can be heated to get to dehydrated by Bayer's process. So this process is called leaching, and these are all the total processes involved in the metallurgy. So among which in this video we have seen only the ore concentration part alone. So we have seen gravity separation or hydraulic washing and froth flotation, magnetic separation, and last by leaching, which is a chemical processes. Thank you.
இந்த வீடியோ உங்களுக்கு பிடிச்சதுன்னா லைக் பண்ணுங்க, ஷேர் பண்ணுங்க, கமெண்ட் பண்ணுங்க, சப்ஸ்கிரைப் பண்ணுங்க. மறக்காம பக்கத்துல இருக்க பெல் ஐகானை கிளிக் பண்ணுங்க.